Okay, in this video I want to talk about tectonic plates. Okay, and as I mentioned in the previous video, they're basically slabs of lithosphere or crust, okay? Slabs of rock, right? Slabs of rock floating on the slowly moving asthenosphere. Okay, remember, you have the crust and you have the asthenosphere below it. Okay, so these, think of them as massive plates floating on, think of them as plates floating on water, okay? Paper plates floating on water, that's what it is. Now, there are two main theories for how the plates move on the asthenosphere. So two main theories for tectonic plate movement. One is that the plates are dragged along, as hot magma. Now, magma is extremely hot, semi-liquid rock from the mantle, okay? M for mantle, magma, okay, from mantle, okay? Plates dragged along as hot magma in the asthenosphere, I'll just write asthene for short, to save space, rises up and then flows under plates, okay, creating convection currents. Let me explain what that is. Creating convection currents. Okay, so if I was to draw a diagram, so as magma rises, let's say, magma rises, it then, so as you know, anything that rises falls, right? So heat rises, then it falls, okay, creates convection currents. Convection means hot stuff rises, cool stuff sinks, okay? So think of an apartment building. So when I was on holiday in Melbourne, in an apartment, I was on the 30th floor. On the highest floor, it was actually a cool day that day, but it was really hot on the balcony. My mate at the bottom floor, standing on the ground level, seeing me up on the balcony, was actually cold. So that's an example of convection currents. Okay, hot air rises, cool air sinks. And as the liquid rock floats, as the liquid rock flows, friction between it and the tectonic plates lying above may be enough to move them. Okay, and I'll draw a diagram to explain exactly what I was talking about. Okay. Let me draw these. Okay. Now, when a tectonic plate sinks below another one, the region is called a subduction zone. Subduction zone is where tectonic plates meet, Okay, they're coming together. When plates come together in subduction zone, when they're moving apart, okay, this is called a mid-ocean ridge. This is called a ridge. Okay, a ridge is formed. Now I should write down the mantle here. This is the mantle. Put another plate here. This is the outer core. Okay, so imagine this is the core of the Earth. Mantle on top. That's okay. Now hot rising magma contacts cold crust. Okay, so the hot magma. So the crust is cool compared to the magma, right? And then it sinks via convection. Okay, so hot magma that's rising from mantle contacts, so it comes in contact with cold crust, and then it sinks. And that can cause the movement of the crust, right? That's how it might work. One possible explanation. So the theory of tectonic plates, okay, was first developed. So theory of tectonic plates was first developed in 1962 by the American geologist Harry Hess. Okay, the idea of moving plates. Now, there are many tectonic plates, I should mention, of varying sizes, okay? Many tectonic plates exist on Earth with different sizes. There's 7 that are extremely large, okay? 7 are extremely large, and you've got other smaller ones, okay? Some of them, and these 7 are actually, some of them are bigger than most of the continents. Okay, and Australia actually sits, so here's Australia, a terrible drawing of Australia. It actually sits right in the middle of a tectonic plate. Okay, you've got the Antarctic plate here next to it, and you've got the Pacific plate next to it, and the Pacific Ocean. Right, so that's where Australia is, sitting in the middle of the plate.